Hello everyone! Kumusta kayo dyan? In this video, we will be working on some examples from our previous lesson on sequences and series. So, shall we cut to the chase? Here we go. For our first example, we will do the following. Okay, so as you can see on our screen, we are going to find the first four terms of the sequence a sub n is equal to -1 raised to n plus 1 times n squared. Mm, in sequences that are given in formulas like this, all you have to do is substitute. Substitute, substitute, yes. But what exactly are we going to substitute? Well, as you can see here, um, a sub n is equal to blah 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 blah. Our variable is n. Recall from our definition of sequences that the domain of a sequence is the set of positive integers, set of counting numbers. So, paano ba tayo nagbibilang? We always begin with 1, and then 2, and then 3, and then 4. So that's what we're going to do. Since we are only looking for the first four terms, we are going to use the values 1, 2, 3, and 4 for our sequence. Pero paano yun papasok doon sa formula natin? Here we go. So, let's just copy that formula first, ano? A sub n is equal to -1 times, raised to n plus 1 times n squared. What we are looking for are will be the values of a sub n given that n is equal to 1, 2, 3, and 4. So let's begin with n plus 1. So this substitution will be pretty straightforward, right? And once we do the substitutions, we will be completing the operations using PEMDAS, as you can recall from your basic education. Okay, so here we go. When we do substitute, we replace the variables with the number. So we're beginning with n equals 1. So for n equals 1, we have a, the n will now be replaced by 1. A sub 1 is equal to, copy the -1 there. The n will still be replaced by 1. Of course, the plus 1 will be copied. And then the n will be replaced by 1 squared. Make sure you have not missed any instance of that variable. Huh? Make sure that every variable in that formula you have already replaced with the given number, which is 1. So, to continue, so we have 1, -1. 1 plus 1 is equal to 2. And of course, we still have 1 squared. Recall, when we have exponents, we do not multiply by the exponent. No. Remember that the exponent tells us how many times a certain number, a certain value, is to be used as a factor. So in this case, -1 squared, it does not mean -1 times 2. No, that's a common mistake. Beware of that. It means -1 times -1. And what is -1 times -1? That is 1. Yes, 1 times 1 is 1. And remember, two negative numbers, when multiplied together, will give you a positive product. Okay? So that's 1. How about the other exponential expression? 1 squared. 1 times 1. That is 1. 1 times 1, of course, is 1. So our first term is 1. For our first term, we have 1. Now let's continue. We have now n equals 2. We're looking now for the second term. So in similar fashion, we have a sub 2 is equal to negative 1 raised to n will be replaced by 2, 2 plus 1, and then the n will be replaced by 2 again, 2 squared. In similar fashion, negative 1, 2 plus 1 will be 3, and then 2 squared, you copy that. Okay, remember, remember you do not multiply by the exponent. The exponent will tell you how many numbers, how many instances, how many times you will use that number as a factor. So negative 1 times negative 1 times negative 1. Basically, 3 negative 1s multiplied together. Okay? Negative 1 times negative 1 will be 1. And then 1 times negative 1 again, that's negative 1. You will notice when you have a series of negative numbers, no, a tip for you would be to count how many negatives there are in your product. No? If the number of negative numbers to be multiplied is even, then your product will be negative. But if the number of negative numbers in your product is odd, then your product will be odd. Tip yan. So, let's continue. 2 squared, 2 times 2. Sir, kala ko ba hindi tayo magmumultiply by exponent? No. It just so happens that the 2 here, it just so happens that our given number is 2. And that we will be using this number 2 how many times? 2 times. So that's 2 times 2. 2 2's multiplied together. Got it? So 2 times 2 is 4. And negative 1 times 4 would be negative 4. Our second term is negative 4. First term is 1. Second term is negative 4. Now, in similar fashion, we have n equals 3. A sub 3 is equal to negative 1, 3 plus 1 raised to times 3 squared. And then negative 1, 3 plus 1 would be 4, 3 squared. The number of negative numbers is even. We have the exponent 4 there. 1 negative 1 times negative 1 times negative 1 times negative 1. We know that negative 1 times negative 1 is 1. Negative 1 times negative 1 is 1. 1 times 1 would be 1. Times 3 squared. 3 times 3. So that's 9. 1 times 9 is 9. Our third term is 9. Finally, we have n equals 4. A sub 4 is equal to negative 1, 4 plus 1 times 4 squared. Sorry for the space constraints. Okay. Negative 1 raised to 4 plus 1 is 5. And then we have 4 squared. Negative 1 to the 5th power, we have an odd number of negatives. So our product would be negative. So negative 1. Now, 4 squared. 4 times 4, that would be 16. So negative 1 times 16 would be negative 16. So, in summary, so we have the terms are, so to answer the question, the original question, which is to find the first 4 terms of that sequence, the terms are 1, negative 4, 9, and 16. Remember to write your answers in order because we're being asked for the first four terms. So definitely you will have to give your answers not in random but in order. First term, second term, third term, fourth term. Okay? So, if you have questions, well, feel free to give me your questions to ask me. But now that I think we don't have questions, let's proceed to the second example. What is the 17th term of the sequence 4, 11, 18, 25? Well, it will be easy to say. It will be easy to maybe one straightforward way for you to do this is for you to continue the sequence. But in many cases, in many cases it would be it will take you too long. Okay. But anyway, we have a formula for this, if you can recall. That is a sub n is equal to a sub 1 plus n minus 1 times d. How do we know this? How do we know that this is the formula we're going to use? Because you can see from the sequence itself. If you inspect the sequence, you will see that this is an arithmetic sequence. If you can recall, arithmetic sequences, they're a sequence of numbers that share a common sum. In which the next term will be obtained by adding a common number, which we call the common difference. In this case, 4 plus 7, we started with 4. To get 11, we have 4 plus 7. The next term would be 18, which we got by adding 11 and 7. 4 plus 7 is 11, 11 plus 7 is 18, 18 plus 7 is 25, and so on. Right? So, given this formula, given the formula, so to get the nth term of the sequence, which is a sub n, we are going to use the first term. So we are going to for us to be able to use this formula properly, we identified the given values first. So we have a sub 1. A sub 1 is our first term. In this case, we have 4. Now, what is our common difference? We have already identified by inspection earlier that the common difference is 7. The common difference, remember, is the number you add to every term in the sequence, in the arithmetic sequence to be exact. Okay? In this case, we have the common difference of 7. Now, what is n? Well, this is the number. This is the 7. We're looking for the 17th term. So our n is 17. Right? Now, given these values, we will now be able to find a sub n. A substitutions lang. A sub 17 is equal to. So we're looking for the 17th term is equal to a sub 1 plus n is 17 again minus 1 times 7. Our a sub 1 is 4 plus 17 minus 1 would be 16 and then 7. And then this is, you can do this with calculators. You can do it mentally if you can. It doesn't matter really. So 4 plus 16 times 7 would be 112. Just confirm with your calculators if you can, if you want to. 4 plus 112, you have 116. So, if you're going to answer the question, a sub 17, the 17th term of this sequence is equal to 116. Alright, so that ends our next example. Our last example for this video would be this. Find the sum of the series 1 plus 1 plus 1 half plus 1 fourth plus 1 eighth plus 1 16th plus and so on and so forth. Remember that the ellipsis, the three dots, mean that the sequence continues on and on and on. Goes on and on and on. Yeah, like that. Okay, by inspection, you can see that the terms of this sequence are a geometric of this series form a geometric sequence. How do we know? We started with 1, we started with 1 half, we started with 1 fourth, then continued with 1 fourth. So this is one. So this is 1. This is 1 half, 1 fourth. 1 fourth can also be written as 1 over 2 squared. 1 over 2 is 1 over 2 raised to 1. The the fourth term, which is 1/8, 1 over 2 cube, like that. Another would be, what's this? 1 over 16 would be 1 over 2 raised to 4. 2 raised to 1, 2 times 2 is itself 2. 2 squared, 2 times 2, 2 cubed, 2 times 2 times 2. So that's 8. And so on and so forth. So if the pattern would continue, the next term in this series would be 1 over 2 to the 5th, which is 1 over 32 plus 1 over 2 to the 6th, which is 1 over 64, and so on and so forth. Right? So, given that we have this, a geometric sequence, remember, is a sequence in which you get the next term by multiplying a number, multiplying a term by a common multiplier, which we call the common ratio, which is R. So, in this sequence, in this series, when we get the sum, and by the way, since we have an ellipsis here, we can say that this is a geometric series. If we're going to find the sum of a geometric series, we are going to use the formula, this one. A sub 1, S is equal to A sub 1 over 1 minus R. The sum of the geometric series is equal to the first term divided by 1 minus the common ratio. Right? So, we're going to identify the values. A sub 1 is equal to the first term here, which is 1. The other variable we have is R. Remember from our inspection earlier, we have 1, and then we have 1 half, we have 1 over 2 squared. You see, the next term, 1 half, you can obtain by multiplying 1 by 1 half. 1 times 1 half is 1 half. 1 half times 1 half is 1 over 2 squared, or 1 fourth. And then 1 fourth times 1 half again, you have 1 over 2 cubed, which is 1/8. And so on and so forth. So, our common ratio, the common number which we have multiplied to every term to get the next term, is 1 half. So, now that we have these values, we can now substitute these values into our formula for infinite geometric series. S is equal to A sub 1, which is 1 over 1 minus, our R is 1 half, which we can operate on further by, 1 minus 1 half. It's like we can use the common denominator, which is 2. Remember, 1 over 1. Okay? Copy the minus 1 there. the negative 1 here, the minus 1 there. 2 divided by 1 is 1. 1 times 1, 2 times, sorry, I repeat that. 2 divided by 1 is 2. 2 times 1, the numerator, is 2. So, what's next? 1 over 2 minus 1 here is 1. 1 over 1 half. So we have a fraction, we have a number, we have our numerator divided by a fraction. And remember, when we divide by a fraction, what we do is we copy the numerator 1, and then we proceed instead to multiplication, and then use the reciprocal of the divisor or denominator. So 1 over 2, the reciprocal would be 2 over 1, which is equal to, okay, 1 times 2 is 2, divided by 1 is 2. So, what we can say is the sum of the series, if you continue this series, the answer would, the total sum of all these fractions of this entire series will be equal to 2. Okay, does it make sense ba? Some of you may ask this. Does it make sense ba? Inad namin lahat ng fractions na yan, tapos ang magiging sagot lang pala ay 2? Well, we can use calculator to check it. Okay, now that I've mentioned it, sige, gamit tayo ng calcu. So, let's try that. 1 plus 1 half plus 1/4 plus 1/8. Can we continue that pattern? Plus 1/16. 31 over 16. So if we ended in that term, 1/16. 131 over 16, if you convert it to decimal, you can use this S to D na button sa ating calculator, no? If you're using Casio FX570. 1.9375, which is, I think, already close enough to 2. Yes sir, paano yan? Hindi naman eksaktong 2 yan eh. We can continue the series. We can make it longer. How do we continue? Plus 1 over 32 plus 1 over 64 plus 1 over 64 plus 1 over 128 plus 1 over 256. Okay. So that's our answer, no? 511 over 256. If we convert it to decimal, we have it like this. 1.996 blah 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 blah. It's getting closer and closer to 2, although it really didn't become 2, as we can see here in our calculation. No? But if you continue that, the answer, your sum will still be closer and closer to 2. This concept of approaching a certain number is a concept mostly used in calculus, which is the concept of limits. So, yung mga STEM students, they will be very familiar with this concept. Now, for our purposes, we will not touch on that, and it's beyond the scope of our video for today. So, I hope you have you have picked up a thing or two about sequences and series in our video for today. So, um, take care always. Lagi kayong mag-iingat. At namamalagi po, meron pa rin COVID-19. So, lahat ng mga pag-iingat natin kung lalabas tayo, make sure to comply with them. So, this is Sir Dansen, and thank you for watching, and thank you for the opportunity for me to share my knowledge with you. Bye!